Today is about balancing. So when I look at this equation, I see that it's CXHY. Any carbon with any number of atoms mixed with a hydrogen with any number of atoms is called a hydrocarbon. This guy is burned in oxygen, that's its fuel. And hydrocarbon combustions always have the products of carbon dioxide and water. Okay? Products are what was created. Reactants are what we started with. So anytime you see a hydrocarbon and oxygen, you don't even have to have the answer over here for the products. You know it's always carbon dioxide and water. Okay, so I'm going to add my little numbers here. I'm going to make my chart, reactants, elements, products, and I'm going to fill in CHO. Combustion is always CHO with balancing the C first, then the H, then the L. 3 C's, 6 H's, 2 O's, 1 C, 2 H's, 2 plus 1, 3 O's. And so I start with the C first. I always go to the side that's lower, so I'm not going to change the left side. I can't take away carbons. I go to the side that has less, and I have to up it to 3. I can't make it C3O2. That doesn't exist. I can only change the coefficients. Once the formulas are written, you can only change the coefficients. So I need this to get up to 3. So what times 1 is 3? 3 times 1 is 3. And that affects my oxygen too. So my oxygen is now at 3 times 2 is 6, plus 1 is 7. Hydrogens, 3 on the left, or 6 on the left, so I have to get 6 on the right. What times 2 is 6? 3 times 2 is 6. And that affects my oxygens too. So now my oxygens are 3 times 2 is 6, plus 3 gives me 9. All right, so now my carbons are balanced, my hydrogens are balanced, and my oxygens are last because they are uneven. Now up until this point, you've had an even number on this side. But today you have an odd number. Now you can use the even odd rule, but I actually don't recommend it because that messes up your other numbers faster. For combustions and only combustions, use fractions. And you're going, oh, I don't want to use fractions. It's not so bad. Don't use the even odd rule, but do use fractions. Okay? 9 cannot be split into 2 evenly. But what is it? 9 halves or 4.5. Whichever one you're more comfortable writing, use that. And you can use a calculator. 9 divided by 2 is 4.5. So whichever one you're comfortable writing it with. So now I have the coefficients listed, and I'm going to add a 1 here. Because remember, especially if you're plugging this on the computer, you can't leave that blank. So it would be 1, 4.5, or 9.2, 3, and 3. Now, that doesn't give you full credit, just like in math. Because math, we don't want to leave the fractions there. So don't leave it in fraction form. Multiply everything by 2. Multiply, and when I say everything, I mean every coefficient, because remember, the only thing I can change is the coefficient. So when I say everything, it has to be the only things that I can manipulate, which are the coefficients. So 1 times 2 is 2. 4.5 times 2 is 9, or 9 halves times 2 is 9. Either way that is comfortable for you to write. 3 times 2 is 6. 3 times 2 is 6. Now, since you did all this extra work here, you can leave it like this. You don't have to rewrite it, okay? You do want to go back and double check and make sure there was no errors. Okay? So carbon, 2 times 3 is 6 on the left side. On this side, 6 times 1 is 6. Okay, carbon is matched. Hydrogen, 2 times 6 is 12 for the left. 6 times 2 is 12. So hydrogens are good. Okay, so we're looking good. Even though the numbers are a lot bigger, we're still on track. Oxygens, 9 times 2 is 18. Over here, 6 times 2, which is 12, plus 6 times 1 is 18. Conservation of mass was met for carbon, hydrogen, and oxygen. We didn't magically create things. Matter cannot be created nor destroyed. So I recommend when you're doing combustion that you have 2 charts. Only 1 chart is required for full credit. So you could just update this chart as well. Okay, in which case this would be a 6, a 12, an 18, a 6, a 12, and an 18. Check. So either way you want to do it, make sure your chart at the end matches your final product so you get full credit.